Okay, if you're looking at number 4, it says how many different ways can $7.15 be paid with 50-cent pieces, 25-cent pieces, and 20-cent pieces. So the total number of 50-cent pieces plus twice the number of 20-cent pieces shall exceed the number of 25-cent pieces by 31. It's a mouthful, and I'm not trying to memorize anything. I certainly have the document in front of me, but I am going to go to the whiteboard, and I need to write things down, by the way. And like I always say, one step at a time. So in number 4, and again, I'm going to talk pennies, by the way, and I'm going to say X is the number of 50-cent pieces. It's the number of 50-cent, I'm going to say coins. And I'm going to go on to say Y is the number of 25-cent coins. All right, you can have 1 coin, 2 coins, so forth and so on. Let's take a look. We also have Z is going to be the number of, what other coin did they have? I got to read that again. 50 cent, 25 cent, and 20 cent. Okay? So what do they tell me? They tell me they have 715. So I'm going to say it comes from this over here. So every coin I have in the 50 cent gives me 50. The next one's going to be 25Y. And the next one's going to be 20Z equals 715. And what do I notice immediately about that? I'm going to say, I'm going to divide through by, I'm going to think about that. What number do I want to divide through by? Certainly a 5. Let me put this over here. So you have 10x, 5y, 4z, and 5 into 715 now. Once 5, 21, 4, 15, 3. So 143. Okay, let me get my eraser out. I'm going to try to erase some of the distractions here. I'm still going to go back and read the problem by. And how many ways can 715 be paid out? 50-cent pieces, 25-cent pieces, 20-cent pieces, so that twice the number. Okay, let's put this over here. Twice the number of 50-cent pieces. I'm going to keep reading it. So twice the number of 50-cent pieces plus twice the number of 25-cent pieces shall exceed the number of 20-cent pieces by 31. All right. I got something there, don't I? Oh, you know what? I think I wrote something down wrong here. Let me just go back and read that again. I got to be careful what I just read. So that twice the number of 50-cent pieces, that's 2x, plus twice the number of 20-cent pieces. The 20-cent pieces are actually Z, by the way. And again, just go back over, read that again. Exceeds the number of 25-cent pieces, that's Y, plus 31. All right. Let me write this down next to this one over here. So I have 2x plus 2z equals y plus 31. All right. Now, did they say anything else? No, they just want to know what the possibilities are at this point. So I have these 2 equations, and there's 3 unknowns in it. I'm going to try to get it into 2 unknowns at this point. And the way I'm going to do that is I'm going to take this equation here, and I'm going to write down 2x plus 2z minus 31 is equal to y. And I'm going to take this y and plug it in here and see what we come up with. Let's put this down. You get 10x plus 5 times y. That's 2x plus 2z minus 31 plus 4z equals 143. But I want to point out that these numbers here are integer. Maybe I shouldn't say integer. Maybe I should say they're really just natural numbers. Maybe I should say whole number. However, whole number would include 0, and I don't think they're would be quite truthful if they talked about, having 0 of those coins at this point. But anyway, let's go work through it. And what do you get over here? 10x, 10x, 10z, minus, that's 155, plus 4z equals 143. And boy, I got some work to do here, don't I? I got 20x. That's done. I have 14z. I'm going to take this and bring it to the other side. So it's really 143 plus 155. That's going to give me 8, 9, 298. Again, I'm always looking to reduce the size of the numbers. And I'm looking at this thing over here, and I'm going to divide through by 2. And what do you get? You get 10x, 7z, and 2 into 298. $149. Okay, I'm going to solve for z, and this is a diaphantine. You might say, can you just look at it and know what the numbers are? Not really. I'm going to have to think about it myself. It's 149 minus 10x over 7. And this is always a problem for me, finding an integer solution to the problem, by the way. And I'm going to look at it. And, one thing I know about the 7 is, I want the top to be divisible by 7. And one way to do that is just kind of look at the top and get it to be a number that's divisible by 7. And I'm seeing a 49 there, but the 100's kind of upsetting me. So what I do, I would pick x to be 10. All right? So if x is 10, I get my first integer solution over here. Let's write this over here. By the way, I made a mistake in the copy. So I'm going to say x is 10. What's the z going to be? Well, it's going to be, the z is going to be 149 minus 100 over 7. And 149 minus 100 is going to be 49 divided by 7, and that's 7. So I'm going to say z is 7. Now, by the way, I'm not saying it's an answer to their question, by the way, but it's certainly an integer solution that does make sense, by the way, 10, 7. It makes sense because I know they have to be, like whole numbers. So what I'm going to do over here, I'm going to make a little table up, and I'll put this over here, x and z, and I got my first integer pair, which is 10, 7. By the way, there could be others. Actually, could be. There's definitely others. It's a diaphantine. There's an infinite number of integer solutions, by the way. So what I need to do is I need to rewrite z as, I'm going to talk about the slope of it now. So minus 10 over 7x, and then it's going to be plus 149 over 7. So what I know about this over here is that there's a marching pattern to it. And the marching pattern is going to be, this is a slope, so minus 10 over 7, all right? So it marches from integer to integer. All right, now if I look at it, and I'm going to say, let's take a look at that. And I'm kind of looking at that, and I want to get the next number. And this is going to be the rise, and that's going to be the run. All right? Now the run is the x things, and the run is 7, so I'll put 17 here. All right, but the rise is minus 10, and that would give me minus 3. This is not good, by the way. You may wonder why that is. It's a negative number. I can't have negative coins, right? So let's go backwards, all right? And I'm still using the run, but I'm going to go backwards now. This would be 3. Again, the rise is 7. I'm sorry, the run is 7. So this makes sense. Now, again, you might say, could I go even further back to that? Not really a negative number. So it looks like you're getting 2 numbers here, 3 and 10, all right? Let's talk about the, this over here is going to be 17, all right? So let me write this over here. One possibility, and again, I'm going to write this down as x, y, z, and I got 2 possibilities, x, y, z, all right? Let's write this down. So x could be 3, the z could be 17, the x could be 10, and the z could be 7. By the way, someone says, how do you get the other guys? Well, I got to go back and figure how to get the y. And the y is, I guess I could get it here, right? So 2x, 2z minus 31. Write this down. 2x, 2z minus 31 is equal to y. All right, let's write this down here. So it's going to be 6 plus 34 minus 31 would be the y value. Well, that's going to be 40 minus 31, which is going to be 9. Let's do this one over here. What do you get there? 20 plus 14 minus 31 is equal to y. You get 34 minus 31 is equal to y. Y would be equal to 3. All right? So let me just see if I can answer their question now. And, I'm not going to write down the sentence, by the way. But they say, let me just read that again. In how many different ways can this be paid out? There's 2 ways. The first way, let me make sure I'm saying this right over here. I got to remind what these x, y's, and z are. And that was, let me see where, I'm sorry. X is 50, 25, and 20. Okay, 2 ways to do it. And 50, 25, and 20. So first way, 3 50-cent coins, 9 25-cent coins, and 17 20-cent coins. The second way it could be done is going to be 10 50-cent coins, 3 25-cent coins, and 7 20-cent coins. And we're done. Thank you.